Hello everyone, today I will introduce a variable frequency power supply, the operation of this frequency converter power supply. The first step, we first connect the input wires properly. We can look at our wiring labels. Here is the input OST, 380 volts. This is the neutral wire. This is the ground wire. Because we are in the testing stage, the ground wire is not connected for the moment. The user needs to connect the ground wire. This is the output side, UVW, and the output 0 line. Now that we've finished wiring, we'll turn on the power. We have already connected the power and turned it on. Take our multimeter. Set to AC voltage. Let's confirm if there is any problem with the wiring of the input. First, we measure the voltage. We measure the voltage between R and N to be around 220. Test all three groups. Okay, no problem. Let's check the line voltage, which is about 380. After confirming that our wiring is correct, turn on the input power switch. At this time, our panel starts to display, and this switch is the switch for the panel display. If we press it here, the panel will not display. If it doesn't display, we turn on the panel. Turn on the power switch. Then we will see a stop key here. There will be an indicator light flashing on the stop key. This is our internal precharge. And when it stops flashing, we can press the green start button to start outputting voltage. The voltage display here is the phase voltage, which is the voltage between live wire and neutral wire. This is the voltage display. This is the current display. This is the frequency display. This is the power display. Then let's talk about the functions of some buttons in this part. First, this knob is the most commonly used one, which is used to adjust the voltage. Let's take a close look. When I turn this knob counterclockwise, you can see the voltage is decreasing. When adjusting clockwise, it increases the voltage. This is the knob for adjusting voltage. Okay, and then there is a yellow button here, called the switch button. There is a corresponding indicator for UV. It is used to switch between voltage and current display. Now we are showing the U phase. Press this switch button once to switch to V phase. V phase will be displayed here, and then switch to W phase, and we switch to the display of the W phase. This is for our convenience to observe 3 different voltage and current. Okay, and then this key is called PF. The PF key is for switching between power factor and power. We will see. Now there is a W here. It indicates power display in this window. It shows the power. If we press the PF light will light up, and it will show the power factor here. Since there is no load now, so the power factor is 0. If there is a load, it will show the power factor. The maximum power factor is 1.0, which means it's very good. Then, the next key is the high and low gear key. We can find that it is currently in high gear mode. At this time, you can see that there is no response when we press it to switch. This is our unique feature. We have made an interlock to prevent switching between high and low pressure while working, which will cause a big impact, which is damaging to the load. In this state, we need to press the stop button first. And let's observe again. It's around 220 volts right now. It is in high gear mode. When we switch to the low gear later. Okay, now, we can switch it now. I can hear some noise. The contactor is switching. Then this low gear, and the indicator light of low gear is on. Let's start it again. We will find that it was around 220 volts, and now it's about 110. That is to say, low gear voltage is half of the high gear voltage. Next, let's take a look at the frequency. Now the frequency is 50 Hz here. Let's take a look at the dip switch. The white one here is the decimal point. This is the single digit. This is the tens digit. This side is the hundreds digit. So we can see that this is 50.0 Hz. So this is 50.0. So what should we do if we want to switch the frequency? We usually suggest customers we stop it in the shutdown state. If I want to switch to 60, I'll switch it to 6. That is, the 10 digits are switched to 60 Hz. Let's check the start again. then it will become 60 Hz here. And to verify whether this is the frequency of 60 Hz, we connected an oscilloscope. This is the real feedback to you. We can see the frequency here. Now the frequency is 60 Hz. This is 60 Hz. If we switch to 50 Hz, it's now 50 Hz. Let's take a closer look here. It's 51 Hz. There is a little error value. So it's just a frequency display. Then let's take a look at the waveform we output this time. This waveform is very beautiful. This is a very standard sine wave. So the power supply output is an AC power supply with a perfectly standard sine wave. Basically, the general operation functions. We will stop here. If we want to stop, we just press the red stop button directly and stop it. This is the output power switch. After we adjust all the voltages and frequencies, we adjust them all. After we adjust all the voltages and frequencies, connect the load, we can close the input switch.